Thank you, Mr. President, sir, Dr. Vijay Rao, for your kind introduction. Good morning, ladies and gentlemen. And first of all, I would like to thank the Executive Committee of IOH Mumbai branch for nominating me for this oration, and the jury, of course, for bestowing me this prestigious Sir Oration Dalal Memorial Oration. So what I would like to propose in the next half an hour is take you through a real hardcore occupational enzyme safety and surveillance for workers working with detergent manufacturing. So the agenda for today's program is I'll give a quick overview of the business of HUL, followed by a snapshot of the manufacturing process involved for enzymatic detergents. What are enzymes and what are the potential occupational hazards due to enzymes, particularly? Sites, the medical surveillance program which has been done at HUL, and finally some key take-home messages. Business overview, as many of you must be aware, HUL is the largest FMCG in India with a turnover of more than 50,000 crores for the last financial year 21-22. It has an employee base of 21,000 employees across 31 manufacturing sites and 10 office locations in India. We have got 5 major business groups or verticals, namely the beauty and well-being, personal care, home care, nutrition, and ice cream. And our brands are available across 8 million stores through 4,500 plus distributors. 50 plus brands. And on any given single day, 9 out of 10 households use one or more brands in India, right? And amongst the top 100 trusted brands in India, 12 are from HUL. So from business robust performance, we have, from a people perspective as well, we have been nominated as employer of choice in the industry for 12 years in a row. So that's coming to manufacturing of enzymatic detergents. As you are aware, HUL, the core business is manufacturing of detergents, and detergents broadly are classified. Today's topic is basically focused on enzymatic detergents. Currently 8 sites in India, 2 in North, which is Rajpura in Punjab and Sumerpur in UP, HURC in Mumbai, Chiplun in Maharashtra, Amli Dapada in Dadra and Nagar Haveli in West, and then 1 site, Pondicherry in South and East in Haldia. So these are the enzymatic detergents. Now for today's talk, I've taken Dapada for which is involved in the manufacturing of detergents, both enzymatic and non-enzymatic. So if you see in this picture, unit 1 of non-enzymatic detergents, which are basically Rin, Vim, and Wheel. These are the major products. Whereas unit 1 powder plant is basically focused only in the manufacturing of. So this is over a pictorial representation of actual plant, which is unit 1 powder plant involved in manufacturing of enzymatic detergents. Now if you see, it has got 3 floors. The uppermost floor is the RM floor. Then we have the second floor, which is the NAREC floor. Then the first floor is the mixer floor. So the first step in manufacturing process is batch mixing in mixer. So liquid and raw materials are mixed in mixer out here on the first floor, and this is the first step. After that, milling takes place. So powder from PSM mill through a cage mill, which is on the back side of the first floor to prevent excessive lumps. And then the mixing and the dosing takes place. So enzyme storage is out here. From here, the enzymes are dosed into the Plowsphere mixer, in the Boon mixer, which is out here on the second floor. And that's where the enzymatic formation takes place, right? And the final stage is where packing of powder happens in the ground floor, which is the packing section. And from here, the finished goods are disposed. The idea of giving this is a snapshot of the manufacturing process so that you can understand what are the occupational hazards that can occur and what are the preventive measures that we are taking place. So from an occupational health point, if you see, all the operations are automatic except for unloading of raw material, and that to only the powder form. Otherwise, the entire process through the pipes and all. So basically, the possibility of occupational hazards due to exposure to raw materials is absolutely minimal. But yes, for us, as an occupational health concern, because we are using enzymes, it is a concern for us because most of you must be aware that enzymes are potent respiratory stimulus. And if an individual gets sensitized, if he's exposed to enzyme dust, then can lead to occupational allergies and occupational asthma, which is a major concern for us. Coming to occupational health hazards, just give you a brief about what are enzymes. We all know that they are chemicals. They are produced by living organisms, by fungi, bacteria, and yeast, and they are essential to life. Why enzymes are important in detergents? They increase the cleaning property of detergents. They break down the stains at low wash temperatures. They provide color and fabric care benefits. And most importantly, they reduce the quantity of detergent in the formulation. And there are various types of amylases, cellulases, and manases for removing various types of stains on the clothes. And how does exposure happen? As I said, to achieve respiratory sensitization, the enzymes must be inhaled. And for that to be inhaled, it must be present in the air or an aerosol, raw material or dust from an intermediate or from the final product as well. So this is how the exposure happens. And then the most important, as we said, it's a respiratory stimulator, so it results into allergy, respiratory allergy, and on inhalation of that enzymes, the individual becomes sensitized. Now, one should remember that sensitization by itself is not a disease. It only to then follow up whether he's having any clinical symptoms or there are any changes in lung function test. And if there is exposure, then it can lead to clinical manifestation. So two main hazards, as I said, occupational allergy in the form of allergic rhinitis or conjunctivitis and occupational asthma. The symptoms are the same as with any other asthma, but most important thing we need to note is that occupational asthma, if it is not diagnosed in the early stages then it can lead to worsening of the situation and safety of the individual, right? We have taken some concrete steps to ensure safe handling of the enzymes. We have a robust structure in place within Unilever with clearly defined roles and responsibilities. At the global level, we have the ESSG, which is Enzyme Safety Steering Group, which is basically to provide oversight for safety and health strategy for enzymes. And also it reviews the performance of the cluster on a quarterly basis. Then we have the enzyme. This is mostly to provide expertise in the domain of air monitoring of enzymes. So it will provide support to R&D function if there's introduction of new enzymes, then in the development and maintenance of analytical methods to measure airborne enzymes, supply of calibration methods, standards, and finally, the maintenance and update of lab audit checklist. Then we have the ECC, which is Enzyme Control Center. Again, this is at the country level, and their main role is to conduct sites in line with the standards, reporting of audit and performance results to the site cluster VP, and then focus on improvement plans. Then we have the engineering director at the supply chain, equipment and process design, which will help in provision of enzyme safety. And finally, we have the technology manager who will basically be responsible for the serology program, which is a part of health surveillance. And he will coordinate with all the sites, report of results, and then coordination with clearly defined roles and responsibilities. And in standards and guidance documents, and credit goes to Dr. Raj Gopal, who is here, who was the global head then, for formulating the standards. So we have the safety risk management of enzymes in home care. This is the main standard which tells you it clearly enumerates the principles of enzyme safety, what needs to be done, and then supported by what needs to be done. So we have the safety handling of enzymes in home care, we have the license to operate document, and finally the health surveillance program for employees as well. So this ensures that there is consistency across all the safety operations. Yeah. Enzyme safety, we have three main principles or the pillars of enzyme safety in Unilever. The first one is engineering controls, the second is workplace monitoring, and the third is medical surveillance. Now, the purpose of engineering controls, as we all know, is to ensure that the exposure is minimal or within the occupational exposure limits. And we have various engineering controls within the plant, as I said. It's containment, it's enclosure, partial or total, to provide ventilation where enclosure is not. Workplace monitoring, we have various methods, and The main purpose is to monitor airborne enzyme levels at the workplace, and this will ensure that whatever controls that we have adopted are working well or not. And then finally, we have medical surveillance, which consists of medical history, respiratory questionnaire, lung function test, and serology, to ensure that employees are not getting sensitized, or if they are getting sensitized, they are not suffering from any symptoms or any ill hazards of the. So to understand the best safety principles for enzyme handling, we need to understand a little bit of how the enzymes are handling the various steps in it. The first one is storage, then there is charging and conveying of the enzymes, then there is dosing, then there is mixing, and finally this is packing. To just give you a quick snapshot, this is the storage area, which is at the backside of the main manufacturing process. So it is away from the main manufacturing process, from the employees, and it is completely enclosed and isolated. Then the second area is the downflow booth out here, from where the enzymes are manually transferred from the storage room to the downflow room, from where the charging and conveying of the enzymes happens. Now, this is the only manual process involved in enzyme handling operations. Otherwise, all the operations are automatic. And from here, from the downflow booth, through suction, it is then transferred to the enzyme storage area. From there, it is mixed with the raw powder, as I said, and then the final enzymatic powder is produced. Yeah. So these are the best enzyme handling practices that we have for each of our operations. If you see, this is the storage area. It is isolated. It is away from the manufacturing process. This is inside of the storage room. The enzyme kegs are well stacked in tidily, and this is the pathway from where it is demarcated in black, so that in case if there is any spillage for whatever reasons, we can immediately identify it. And as I said, the engineering control is isolation, and we have MSDS, SOPs, and RP notices displayed at the location as well. So this is basically the enzyme isolation, which is the best practice, which is used for storage area. Then, as I said, from the storage area, enzymes are then transferred to, this is the downflow booth. Again, it has got partial enclosure, and the discharge of enzymes happens within this downflow booth system. It provides containment and removal of dust and aerosol when the enzymes are being discharged. And there is a vacuum system. If you see, this is a suction pump from where the enzymes are then transferred through the suction pump onto the third floor through automation, right? So I'll just show you a small audiovisual clip, because this is the only manual process where enzymes are transferred. So this is an employee with PPE. He is taking the enzyme keg from the enzyme storage room. He'll safely secure the rack so that it does not fall over. Then he'll ensure that the enzyme storage room is well secured as well, so that nobody else can enter. And this is the downflow booth. It is automated, so he'll have to press the button which is on the right hand side, and then the booth will open. And then he'll wear the entire PPE once he's inside the downflow booth, when the enzymes are actually discharged and transferred. And if you see, this is the suction system. It's an automated system from where from the downflow booth, enzymes will then be transferred to the enzymes silos on the third floor. So this is where the enzymes are getting transferred. Yeah, so once the enzyme transfer happens, this is the enzymes silo on the third floor. If you see, there's a black pipe from the ground floor, it is directly coming into this enzyme silos through this PF system, which is a Swedish system. And again, it is totally enclosed. Okay, it is restricted area. Transfer system, it is clearly marked in black. And then local ventilation is also provided. And there's a manometer also here which checks the local ventilation. And enzyme dosing then happens from this Catron system. This is the Catron system, which is connected to this enzyme silo. And from here, it is then dosed into the boon mixer. Again, this is totally enclosed, if you see. And there's double clamping of all the pipes as well. So the best practice which we are using out here is total enclosure along with ventilation. Then as far as mixing of enzymatic powder is concerned, it is done in the boon mixer. So this is the boon mixer. This is the enzyme line which is coming from the Catron system. And the raw material and the enzymes are then mixed into this boon mixer. And here also we have ventilation and manometers, and there is dedicated vacuum cleaner also in case there is any spillage. And again, this dosing line is marked in black so that we can identify any spillage out here. So here the principle which we are following is partial enclosure and ventilation. Finally, there is conveying of enzymatic powder. After mixing of base powder and enzymes in boon mixer, enzymatic powder is then transferred through this NEREC conveyors to this fibrosieve machine. Again, these are totally enclosed, so there is no chance of exposure. And from the fibrosieve, it is then transmitted to the packing machines. And packing machine section also, if you see, it is totally enclosed. There is no human interface. The humans are here only once the final product is packed, and it is then dispatched to the finished goods areas. Yeah? And there is a DE line as well. If you see on the side, this is a DE line for any dust extraction which is required. And packing machines are all under ventilation with velocity of more than 1 millisecond. And the packing machine offtake conveyors are also fully enclosed. So there is absolutely no chance of exposure at all. This, just a few lines on ventilation. We have dust extraction systems for both packing lines, conveyors, seeing areas, and boon mixer areas as well. There are separate DE lines for enzymatic and non-enzymatic powders. And then there is periodic surveys also done to ensure that they are working well. This is just a pictorial SOP in case there is a spillage. The whole area is barricaded. Then we have this HEPA filters which clears the area. Then it is cleaned with contaminated 10% sodium hypochlorite. And then finally it is pushed into deactivation area. So this is in case it's a worst case scenario, we have to do this. The second most important stage in enzyme safety is air monitoring, as you are aware. And it monitors the levels of enzymes dust, which can be measured by instruments called as Gallis sampler. This is the picture of the Gallis sampler. And air passes through the filter paper, which is placed on the top of the Gallis sampler. These filter papers are then analyzed to specialized machines, and we can come to know the exact level of enzyme in the work environment. And as I said, it enables evaluation of effectiveness of control measures and integration of employee exposure as well. And sampling is done at fixed locations, depending on the risk areas. Sampling is done at city. This is all demarcated and well defined. And the sampling has to be done within 4 hours, and the analysis also has to be done immediately within 4 hours. And there are various positions, as I said, depending on high risk areas they are kept. Important points to note is that they should be within 1.5 meter area, and it should not interfere with the ventilation systems as well. And based on the levels, then we have performance standards. So if the levels are up to 4 nanograms per meter cube, then the area is called as green zone area, which is a safe area. If it is between 4 to 10, then it is in amber. Then we need to do a resampling and check whether it is really high. And if it is above 10, then it is high risk area. Now, as per occupational for safety principles, we have kept our standards as up to 4 only, so which all the areas should be in green area. This medical surveillance program, which is basically purpose, as I said, is to ensure the health and protection of the employees. That is number one. Also to ensure that whatever controls are there are working well, and most importantly, identification of any adverse health effects at an early stage so that it will enable us earlier intervention well. And what is involved? It's a global program, as I said. It is done across all the Unilever sites where enzymatic detergent sites are present. It is done in India at 8 sites. And The best part is that all the medical reports are confidential. The access is given only to the occupational health physician or the factory medical officer. We have an inbuilt medical enzyme surveillance systems for workers as well, and the access is given only to the... As I said, it consists of 4 steps. The first one is medical history, the second is respiratory questionnaire, the third is lung function test, and the last one is serology testing. Now, the frequency and content of medical surveillance is defined. So, on pre-placement, that's on joining, we do all the 4 things, that is history, questionnaire, lung function test, and serology. Employee joins. Every 6 months, we do medical history, respiratory questionnaire, and lung function test. Only serology is done annually after joining, and then the entire program is done on an annual basis after the first 2 years of joining within the... Medical history, as we are all aware, is very important in occupational health. As far as enzymes are concerned, we need to take into note whether any individual is having history of atopy, rhinitis, or smoking. Although it's not an absolute contraindication, but if somebody is having a history and is suffering from allergic symptoms due to any of this, then we can always differentiate between exposure, occupational and non-occupational causes of asthma or allergic symptoms. As far as asthma is concerned, it is slightly debatable, but assessment to fitness is based on the risk assessment by occupational health physician, and there is society guidelines as well, depending on the severity of asthma. So depending on the management protocol, they've guided asthma into 4 groups. Group 1 is if somebody is taking occasionally steroids, inhalation, that is stage 1. Stage 2 is that if there's a regular dose of inhaled steroids or beta-2 dilators, bronchodilators. Stage 3 is that there is a combination of both. And stage 4 is oral corticosteroid as well. So if an employee is either in stage 1 or stage 2, then he may be considered medically fit to be working with enzymes. But again, we need to take medical opinion of respiratory specialist as well. We need to brief him that there is risk and there is frequent... The second is respiratory questionnaire. Again, this is based on the questionnaire developed by International Union Against Tuberculosis, and it contains the same questions which are related to occupational allergy or asthma. So we go through the details. This is done, as I said, on joining 6 months for the first 2 years and then annually every year to really ensure that employee is not suffering from any of the symptoms. And positive responses, as I said, does not mean that the employee is having disease. For sensitization is there, but if there are positive symptoms, then we need to watch out for. The third one is pulmonary function test, and the principles are that we need to have a baseline function to see what is the primary exposure level to respiratory hazards, if any, and then monitor lung function test over time. And obviously, it will be abnormal if FEV1 or FEV is more than 1 liter lower than the predicted value, or it is less than 80% of the predicted. Test is abnormal, then that's a warning sign. We really need to investigate whether it is due to occupational hazard exposure or non-occupational exposure. And all the records are stored for 30 years. The most important in the health surveillance is serology testing, which we focus really hard. And basically, it's a measurement of your IgE levels within the blood. And this tells us whether if the individual is exposed to enzyme dust or not. And if the levels are above 0.34, then the serology test is considered as positive, right? And it only means that the employee is sensitized. But it does not mean that he's having a disease. So serology test is really important for us. Again, the periodicity, as I said, is done it is done annually, which is called as the annual sample. And when if he leaves the organization or is transferred from an enzymatic to a non-enzymatic site, then we do a exit sample as well. And sensitization is not a predictor. There's definitely warrants an occupational exposure investigation, but it is not an indication for job change unless we have associated symptoms or abnormal findings. Now, within Unilever, we have set up some strong key performance indicators for serology program for each site, and there are some important terms that we should be associated with. Uptake rate is basically the percentage of potentially exposed individuals who have provided serum samples of testing. So in simple words, if there are 100 workers who are working in enzymes, Then if 95 have provided blood samples for serology, then the uptake rate is 95%. If all the 100 are provided, then it will be 100%. Uptake rate is more than 95%, so that the results are really statistically significant. Then is the matched population, which is again a group of people who have provided blood samples in the reporting year, that is current year, as well as the previous year. And the KPI should be more than 90%. The third is prevalence rate. Well, all of you are aware that is proportion of individuals with positive serology test to one or more enzyme at any given point of time. But the most important is the incidence rate, which is the rate of newly diagnosed positive serology test to one or more enzymes to which the person did not test positive in the previous years. So this is an important indicator for us, and Unilever has set a very high benchmark of KPI for incident rates to be less than 3%. If there's an increasing trend or if it is more than 3%, then definitely it calls for workplace investigation. We manage a new sensitized case on an individual level. If any individual who is newly sensitized or has positive serology test, he will follow up with an occupational health physician or factory medical officer who will review his medical history and respiratory questionnaire and discuss with employee if there was any possible exposure. And based on the evidence, whether there are respiratory symptoms or abnormal significant changes in lung function tests, he will be then recommended for further monitoring, evaluation, and referral to specialist. He will be temporarily be out of enzyme area. But if there is no evidence, then definitely he can continue to work with enzymes because it is only sensitized, but there are no respiratory symptoms of occupational allergy or asthma. At the organizational level, if the incidence rate is more than 3%, so if the incident sensitization rate is more than 3% for newly diagnosed cases, then there has to be a comprehensive workplace investigation by site team, which will be a factory manager, safety and occupational health physician, and then review of all activities and associated risk assessment was done, which I showed you in my previous slides. There will be a review of hygiene and health surveillance data as well. We'll identify the likely causes of exposure and then have action plans in place as well. This is a busy slide. It's a serology program that we have for the whole year. Important point to focus is that we have program run in 3 stages. First is the planning stage. Then we have the interview management, which is the execution stage, where actually the serology test is confirmed, done. And finally, we have the analysis stage. So what happens in the pre-planning stage? The serology manager sends an email 3 to 4 months advance before the serology test is done to all the site medical officers. The site medical officers will take stock of the situation, how many employees are working in the enzyme site, will prepare a planning pro forma and send those details through our database system. Then actually the serology technology manager will plan, and then serology will be done across all sites at a particular schedule. And finally, we'll have the results of the serological program coming out. So this is our medical surveillance of enzyme servants database system. A very important fact is once we have this electronic database system, all the medical documents are confidential. There's data privacy. And the other important aspect is we can get all reports at the click of a button. So this is just a few screenshots that I have taken actually from our site. If you see, this is the planning performa, which the medical officer will fill. Which is the factory, what are the enzymes which are used, what are the total number of employees, then factory name, and whether it is a baseline sample, annual sample, or exit sample. This is how the planning performa looks like. Then this is the interview details where the employee details are captured at the time of serology. So his personal details, work location details, and what type of sample it is, serology sample. So everything is locked into the database. And then finally, we'll have the analysis performer. Once the serology tests are done, then how many tests have been done. So again, all those details will be captured and will be sent to the serology officer. And the last part is the group summary report. Again, this reports, we can get it from the system. As I said, they are there year-wise, so we can just click on any year and we can get the reports from the system itself. I'll just show you one of the reports for one of the sites. If you see, the incidence rate was 0%. The uptake rate was slightly less. It was 92%, but match population was 96%. And if you see year-wise, this is the prevalence and the incidence rate for each of the enzymes. If you focus on 2021, the prevalence rate is 2 or 1%, and the incidence rate, which is most important, is almost 0%. And this is for each of the employee, for each of the enzymes, the serology test is done. This is at the organization level, the prevalence rate is coming down. It is 3.3. But most importantly is the incident rate, which is almost 0%, which means that our enzyme safety operations are working pretty well. So with that, I would just like to leave a few messages that leadership commitment is the key. For the success of any program, the leadership buy-in has to be there. Otherwise, this program will not be sustainable. The second is that we need to own an ecosystem. We need to take care not only of our own employees, but also the contract labor as well and the community as well. And systems, SOPs in place so that everybody is on the same page. There's no ambiguity at all. Fourthly, we need to leverage the use of technology. As I said, we have the medical surveillance enzyme system, the database system, which will help us in ensuring that there is data privacy, confidentiality, and we get accurate analytics as well. The fifth thing is primary control must be achieved by equipment design through engineering controls as far as possible, as we have demonstrated for enzyme safety as well. And then regular review of all operating procedures and work environment continues on an ongoing basis. So with this, I would like to conclude and just end with our business mantra for HUL, which is health and safety of employees is #1 priority of the business.